Let's go ahead and get started. My name is Dan from Dan's Test Prep. This is Tutor Tuesday. We go over mostly digital SAT math questions, but it can be ACT problems, reading problems, whatever. So I guess let's hear from you guys first. Is there any types of questions that you guys want to go over? Are any of you guys taking your SAT soon? I know there's one coming up in like 25 days in March. I see we want some Algebra 2 stuff. Algebra 2, April. Oh, I didn't know they were offering an SAT in April. Is it like a school day test? Okay. Yeah, extra month. Let's go through some Algebra 2 topics then. That's going to be more of like usually like your advanced math stuff. So I have a couple of topics here. I have equivalent expressions that we can go over. I have nonlinear functions like quadratics that you'll usually see in Algebra 2. And some systems of equation stuff and nonlinear systems of equations. So I guess one problem that we could start off with is this equivalent expressions. This one's actually pretty tricky. And for those of you guys who can't see the stream, I know that's always an issue, I'll paste it in the chat as well. If you manage to solve it before I do, definitely put your answer in the chat. We can compare. But yeah, let's go through this one. It says the equation above is true for all x where a and b are constants. What is the value of ab? Well, to approach this one, there's a few things we can do. First of all, let me get my tablet working here. Yeah. So it's asking us for the value of AB. I might see if I can expand this expression on the left to equal the one on the right. So for that, I would want to FOIL everything out, or I'd want to use the distributive property to multiply this out. So for example, doing multiplying these few terms together, we get 5ax cubed. Second multiplication gives us minus abx. Then we get plus 4ax. We also want to multiply the second term into everything. So we do plus 15x squared minus 3bx and plus 12. Remember, this is equivalent to the right side. So that's equals to 20x cubed minus 9x squared minus 2x plus 12. And what I'm going to do here is I'm going to combine some like terms and then we'll equate the coefficients. Yeah, we know it's equivalent because we have an equal sign here. So anything that I expanded out on the left side should be totally equal to or equivalent to the right side. So starting with the right side, they've already combined all the coefficients. On the left side, we have 5ax cubed. I have this 15x squared, and I have this, this should be minus abx squared, because when I multiplied ax into minus bx, it'll multiply minus abx squared. We have two x's. So I'm going to add here 15 minus ab times x squared. You can see what I did here is I just took any x squared terms and I factored out the x squared and I just combined the coefficients. That way I don't have to write x squared twice. I can just multiply x squared into both of these terms. Then we can add 4a minus 3b times x, right? Because I have these x terms right here. I can just add those together and again factor out the x. And then plus 12. This is equivalent to 20x cubed, and then minus 9x squared minus 2x and plus 12. Some of these parts you can now start matching up. For example, we know that 5ax cubed has to equal to 20x cubed. If it's true that both sides of this equation are equal, then the x cubed terms have to have the same coefficient. So maybe from here you can tell what the value of a should be. In order for this to be true, we need a equals to 4. Actually, we don't even need to solve for a and b separately because we can solve directly in one of these circled equations. If you see here, on the left side, I have 15 minus ab times x squared. On the right side, that's equivalent to negative 9x squared. So what I can do here is rewrite this as 15 minus ab is equal to negative 9. So notice how I dropped off the x squared, right? 15 minus ab times x squared equals negative 9x squared. You can drop off the x squared by dividing it off both sides. Then all I want to do here is I can plus 9 on both sides, and I can plus ab on both sides. I'll cancel this, cancel this. So we get 24 is equal to ab, which is answer choice C. Hopefully all clear to follow there. Nice. Glad. Let's move into a different topic. This is more like nonlinear equations. How do I manage to do the problems so quickly when doing the test? That's always an issue. But I find that if you practice them enough, you'll know, for example, this is absolute value equation. You'll know the steps even before you start to solve it. You know you need to combine like terms. You know you need to set it equal to the positive and a negative of the right-hand side, and then you just solve it algebraically. So the more practice, the more you'll be able to recognize these problems, and the faster you'll actually be able to do it on a test because you've practiced it so much. Yeah, preparing for the SAT, Khan Academy is a good resource. Practice tests on Blue Book are the best source that you can use to get an accurate score. I'm also doing an SAT boot camp, but honestly, I would stick with Khan Academy and Blue Book for quite a while until you feel like you need extra resources. Then you can go searching for more. Khan Academy has a very comprehensive course that you can start off with. This is our nonlinear equations and systems of equations. So this is an absolute value equation. First thing I notice is that I have these absolute value 4 minus x, and I have it 2 copies of it here, and I have 3 copies of it here. So I'm just going to combine like terms to 5 absolute value 4 minus x equals 25. My next step would be to divide by 5 here. Divide by 5, divide by 5. Because I want to isolate this absolute value and get absolute value of 4 minus x equals to 5. From here, there's 2 things you can do. You can split this up into the positive case and a negative case. Either 4 minus x equals to 5 or 4 minus x equals to negative 5. And yeah, we're looking for, when it asks for the positive solution, we're looking for the x value. So I set up these 2 equations because if 4 minus x is equal to 5, then the absolute value of that will also equal 5. Or if the inner part, that 4 minus x, if that equals to negative 5, absolute value turns everything positive. So if this was negative 5, it would become positive 5. So solving this first one, 4 minus x equals 5. If we add x to both sides, plus x, and we subtract 5 from both sides, we can cancel out the 5, cancel out the x. We get -1 equals to x. So we can grid that in, but they would mark that incorrect because they're specifically asking for the positive solution. So it looks like we are going to have to keep solving for the second case, which is that 4 minus x equals -5. So what I can do here is add x. We can add 5 to both sides. So that cancels. And that leaves us with 9 equals to x. So you would grid in 9 for your answer, just positive 9. Alternatively, you can use Desmos. You do like 2 absolute value 4 minus x plus 3 absolute value 4 minus x equals 25. And you see it looks like x equals 9 is where that one solution occurs. Because you can use Desmos on the test, so it just becomes way quicker. Let's do this one. Paste that in there. More nonlinear equation stuff. So this is an exponential equation. Yeah, how should you effectively use Desmos? Honestly, if there's a problem that you can graph out, like with an equation, and you can visualize it, or it asks you to solve for something, you might be able to just use Desmos. I'll show you on this question as an example. We're asked to find the y-intercept of the graph. Conceptually, that can mean two things. Either we substitute in when x is equal to 0, right? Because the y-intercept is just when x equals 0. That's the y-axis. And we find the numerical value. We find it algebraically. Or you literally type this into Desmos. So f of x equals -8 times 2 to the power x plus 22. And then you just ask Desmos to solve it graphically for you. So it looks like the solution is at 0, 14. And then you go here, and that's answer choice A. So you didn't even need to write anything, although you could have. You would have done f of 0 is equal to -8 times 2 to the power of 0 plus 22. Then that -8, 2 to the 0 is 1, so it becomes -8 times 1 plus 22. That becomes 14. A common mistake is when they're asked for the y-intercept, you just take this value of 22. But it's not going to be the case for exponential equations, right? Because you have to evaluate it at x is equal to 0. And since it's to a power, usually that term becomes 1. So it does affect it a little bit. So yeah, Desmos right here. And graphical or algebraic solution gives you the same answer. There is an example of a nonlinear question, nonlinear equations that you can't really solve with Desmos. If you're asked to interpret something, you kind of do have to use, like, you have to think about it. You can't really just like plug it into Desmos and solve. Like this function here, it says it models a number of advertisements sent to its clients, a company sent to its clients each year, and X is the number of years since 1997. If the function is graphed in the xy plane, which of the following is the best interpretation of the y-intercept of the graph in this context? Desmos can't really interpret anything for you. But what I know is that if f is the number of advertisements, then the y-intercept is when f is, so the y-intercept is when x is equal to 0. X is the number of years since 1997. So that means we are in the year 1997. And then the y value would be 9,000. And we know that y is the number of advertisements. So I'm going to look for something that says like the number of advertisements the company sent to its clients in the year 1997 was 9,000. And that's going to be answer choice D. let's look at some other interesting problems that we could. I think this one can be solved with, pencil and paper or Desmos. And sometimes it's a combination of both. So this one's saying the equation above is true for all x greater than 2. R and t are positive constants. What's the value of RT? If you want, you can plug the whole thing into Desmos. Let's see how that looks. 2 divided by x minus 2 plus 3 over x plus 5 is equal to Rx plus t. And that whole thing is going to be divided by x minus 2 times x plus 5. Notice we don't know the values of r and t. I just plugged them in here in the equation. Now it's asking me to add sliders. So I can do that. I can add sliders, and I can see what happens when I change the value of r and t. It's true for all x greater than 2. One thing I can also do is plot these separately. What does it mean for an equation to be true? If this part and this part equal each other, they're the same thing. So I can kind of change the values of r and t until the graph looks identical. Let's say you had no idea how to solve this at all. And you might be able to get pretty close. It looks like this is pretty close. When r equals 5 and t equals 4, it looks like I've matched up those graphs pretty much exactly. So then to values of RT, which would be 20. That's going to be answer choice C. Now, if I wanted to make sure, algebraically, of course, I could do that. What I would want to do is probably just multiply everything by a common denominator of x minus 2, x plus 5. So 2 over x minus 2. We multiply everything by x minus 2, x plus 5. And then we have 3 over x plus 5. That gets multiplied by x minus 2, x plus 5. And that's equal to Rx plus t. And remember, we multiplied by this common denominator, so that cancels out the denominator here. This term can also cancel out, so you get 2x plus 5, 3 times x minus 2 equals Rx plus t. But you can see this, it's a little bit tedious to try to match the coefficients by hand. You can see it takes a little bit of guesswork. It's also tedious to solve it by hand, so like this would be 2x plus 10 plus 3x minus 6 equals Rx plus t. But definitely solving it by hand is more robust. I would get 5x plus 4 equals Rx plus t. And matching up those numbers, I can see r equals 5 and t equals 4. R equals 5, t equals 4. So RT equals 20. And that's again going to be answer choice C. Let's take a look at some more problems like this. I think a common thing you do in Algebra 2 is exponents. Okay. So for this one, we're given something with negative exponents, fractional exponents, and we want to based on the answer choices, it looks like the goal is just to simplify it and convert it into something with roots. Now, the way I would start this one, probably look at the negative exponents first and move them up to the top, or I mean flip the sign side that they're on. So something like x to the negative 2 becomes x to the negative 2. I'm going to move down and become x positive x squared. I'm going to keep the x to the 1/3 here. Y to the negative 1 power can be flipped up to the top as y to the 1. Then really what I'm focused on now is simplifying respectively the top and the bottom. When I'm multiplying two bases together that have different exponents, or multiplying two things together, they're the same base, they have different exponents, we can add the exponents together. So what that looks like is it's actually going to be y to the 1 plus 1/2. And on the bottom it's x to the second power plus 1/3. We're combining those exponents under one base by adding them. This is going to be equal to y to the 3/2. And I guess we can even do the intermediary step, which would be to convert this whole number into a fraction. So 2/2 plus 1/2. And an x to the power 6/3 plus 1/3. That's y to the 3/2 over x to 7/3. We can convert this further into radical form like they want. For example, for a fractional exponent, the denominator is always the root. So the denominator of 2 in the 3/2 means that this is a square root. And inside I'll leave the y cubed. Here it's a cube root of x to the 7th. So those are equivalent forms of writing those fractional exponents. Last thing here is it looks like they took out some copies of x and y, so like I could write this, for example, as y squared times y. And this could be x to the 6th times x under the cube root. Since they were multiplying under the square root, we can split them up into separate multiplications like this. And of course, when you're solving it on your own, you don't need to write out all these steps. But I'm just doing it for clarity here. You can see how this part right here, square root of y squared, simplify to just y. And the cube root of x to the 6th would simplify to x squared. So this becomes y square root y divided by x squared cube root of x. That should match up with answer choice D. You know, at the same time, if you had no idea and you had a lot of time, you could plug this expression as the Desmos, plug in some values for x and y, and see if any of those answer choices matched. But I think it's just about as much time as you'd spend solving it out by hand. Okay. Yeah, on Khan Academy, this is advanced math. If you want to go even deeper, this is the equivalent expressions topic. Usually you'll see that with like the wording, this expression can be rewritten as blank. Yeah, if you solve a problem and you have to round it, that can be annoying. SAT especially, like if your answer is too long to fit, you have to round it. Or sometimes they even ask you to round it to the nearest 10th or 100th. and they'll mark you wrong if you don't round it how they ask. I'm not sure if they're doing that anymore, but on paper SAT especially. Our next advanced math problem, this expression 4x squared plus bx minus 45, b is a constant, can be rewritten as hx plus k times x plus j. H, k, and j are integer constants. Yeah, SAT does not do partial credit, sadly. Which of the following must be an integer? It's a really interesting problem. I haven't seen this type of problem show up very commonly. But it says it can be rewritten in this form, so why don't we try expanding this and seeing what we get? I know that if I multiplied those two terms together, I would get hx squared plus hjx. Then we get plus kx and plus kj. So let's simplify that just one step further. We get hx squared plus hj plus kx plus kj. This is also equivalent to 4x squared plus bx minus 45. So what information can I get from this? I know that right away I know h is equal to 4. So that's a little bit of information that we can use. We also know that, let me do it in a green. We know that kj equals negative 45. Now if I'm looking at substituting h equals 4 in here, the x term, we have bx on this side, we have hj plus k on this side. There's not really enough information because we're still missing j and k, even if we know h. I could rewrite j in terms of k, maybe, but then we still have a b on this side and a j or a k on this side, so not enough equations to actually figure out what those values are. But what I do know is the following. If I have kj equals negative 45, I can manipulate this like so. I could, well, first of all, I'm going to look at my answer choices for clues, but you know, I see the number 45 appear here. We have b and h and k. We don't really know what the value of b is, so I might stray away from those answers. It doesn't actually tell me that b is an integer, it just says it's a constant. Although it should be an integer because it's a sum and product of integers. But anyways, I see this 45 here, I see this 45 here, that gives me a clue. If I divide everything by k, I would get j equals negative 45 over k. We know that j is an integer. Right. If j, yeah, I'm back. If j is an integer, then negative 45 over k must be an integer as well. And negative, positive, it doesn't really matter. It's still the same number. It's just the sign that changes. So 45 over k should be a positive number as well. Or should be an integer. This is an integer. By definition, then, this must also be an integer. There's no way that this is a non-integer. Ooh, that was a tough one. Let's do one more in like the nonlinear functions kind of questions. Yeah, more questions. Unfortunately, this will probably have to be my last one, but because we're a bit short on time. But I will be back next week with even more questions for you. I think this one is a good one to end off on. It says we have a function a to the power x plus b. A and b are constants, and the graph has an x-intercept at 2 and a y-intercept at 0, negative 323. Well, they literally give us points here. All we need to do is set up a system of equations, right? We know that f of x equals a to the x plus b. So why not set up something like f of 0 is equal to a to the 0 plus b. That's equal to negative 323. And I got that information from here. A to the 0 is just 1. Plus b is equal to negative 323. And then b is equal to negative 324. Reason I use 0 to substitute for x is because I have this ordered pair x comma y. And actually you'll see the next substitution I'm going to make is this one, 2 comma 0. Which actually I don't even need to do that because it's only asking for b. I don't need to find the value of a. Though I could now if I wanted to. But yeah, it's just negative 324. Zero also just tends to be an easy number, so that's something people sometimes use to evaluate a function at. But yeah, in this one, it's given as a point. Anyways, I think we'll have to end off there, but I am going to post the recordings on YouTube, and you guys can catch me next week and submit more problems. You can DM me problems. Yeah, we'll see you then.